So, hello, welcome to another episode of Flying High with Flutter. I'm your host, Alan Wyma, and today we have another Manning guest. Manning's been great to supply us with some interesting authors, mostly related to AI. I think since AI is so popular nowadays, it's always good to see what's going on. And with myself, I haven't invested much time into it, but plan to do that very soon. But coming back to the main guest, Abhinav Kimothi, is that right?
That works well. When it comes to our colloquial language, we call it Abhinav Kimothi, but anything is fine. You can also call me Kim because that's like one of my nicknames that I go by.
Oh, well, it's good to have you on. We were just talking before the show about RAG. So your book is called "Simple Guide to RAG." I just shortened the name. It's actually RAG and Generative AI, I believe, was the full title. It's quite a long title. RAG itself actually seems like a pretty straightforward concept, but when I see RAG and the name, if you spell it all out, what's it called?
It's called Retrieval-Augmented Generation.
Why don't I let you kind of do a quick introduction of yourself and talk a little bit about the book and what you kind of cover.
All right. Thank you so much, Aaron. First of all, it's an absolute honor and a privilege to be here speaking to you and to your listeners. My name is Abhinav Kimothi. As you introduced me, I have been in the field of data science, machine learning, and now AI for almost 18 years. I started in 2007. In fact, June was the month when I began my career. So it's been about 18 years. And over the course of last 18 years, I've been involved in data science consulting across different domains and also building AI first products for enterprises. And in my last two stints, so currently I am director of data science at an organization called Sigmoid, which is a data and AI solutions company. And in my prior two stints, I was deeply involved in natural language processing, conversational AI, uh, and then transformers and LLMs and generative AI technology in general. Uh, Previous to my current role, I was developing a SaaS platform that could generate marketing content for brands and enterprises using generative AI. That also seems to be one of the most popular use cases for large language models or LLMs. Okay, so let's talk about the topic in question, which is RAG or retrieval augmented generation. As you said, the term sounds a bit intimidating, but the concept actually is quite simple. And I'd like to take you back to November of 2022. And though the technology had existed for a while before this, when OpenAI released ChatGPT on that fateful day, suddenly the world became very dramatic because now you had this tool or this application which could interact with you in a manner a human being would generally. So everybody was very excited, but along with the technology, people also started discovering the challenges that are associated with LLMs in general. And the biggest critique was, hey, it is telling me something very confidently, but it doesn't seem to be factually accurate. It is cooking up facts, giving me responses that are not up to date, or are plain non-existent. But it is doing it in a fashion that makes it sound real and sound very confident. And people, there was a section of people who were very quick to discard the technology altogether, saying, hey, it is not useful. But actually LLMs are you can call it a revolutionary technology. So there were already researchers who were working on trying to address this problem of hallucinations or lying with confidence in LLM. And one part of the research also focused on this aspect of, hey, what happens if we give the LLMs some data or some facts in the prompt itself? Can LLM integrate those facts and then produce results that are factually accurate? And that is the whole genesis of this idea of retrieval augmented generation, or RAG. And I'd also like to break down this term. So retrieval means, commonly understood, that you are trying to retrieve some information from somewhere outside your system. Augmentation would mean, you augment this information to the prompt that you are sending to the model or the LLM, and then the LLM would do the generation. So this concept is quite simple. You retrieve information from somewhere, augment it with the prompt that you are sending to the model, and then the model generates text or generates information that is factually accurate. So that's what RAG is in a nutshell. I hope I was able to sort of give a context to what this really means.
I mean, it's basically it. I don't know why that term rag is this sounds so complicated. And I remember people talking about it, but I forgot what they said, but I don't know, I just had this idea that it was much more complicated. But I mean, in general, it just makes sense, right? And you kind of start to wonder, like, okay, why is it that we've never had this, and why is it that this is so like revolutionary? You'd figure that LLMs would have this already, but LLMs are not. They don't really work like that, right? They don't have like this kind of data storage that they pull from. I mean, you train them, and then they work based on that, and it's just a training, right, without any kind of memory or knowledge bank, right, like typical humans have, where we say, okay, hot is hot and cold is cold, as opposed to this one. It just, I guess, works off an algorithm, just gives you whatever it says, but it has 100% confidence in it, right?
Yeah.
Um, yeah, I mean, let's talk more about about your book and what you actually cover, and what was kind of the purpose of the book, because I mean, you're not the only person talking about RAG and LLMs, right?
Right. So yeah, like you rightly said, Alan, LLMs as a technology, as a technique or an algorithm, doesn't inherently promise to have any knowledge or be factually accurate. LLMs are just next token prediction, or for simplicity, next word prediction models. You give it a sequence of words, and the way they have been trained, they are able to predict what the next word in this sequence is going to be. And so, like when you do it over and over again, you can come up with coherent text. And because LLMs have such deep neural network, they were able to produce text that was coherent and sounded like human beings. But that expectation from an LLM to be current, to have all the knowledge, to be factually accurate, that expectation is not the right expectation to have from the algorithm. And therefore, we might have come to know about RAG uh, in mainstream discussions after ChatGPT was introduced. But the research around RAG and the concept of RAG has existed since the first LLM was introduced, since BERT, or the first series of GPT by OpenAI was released. The researchers had started, also experimenting with the models, and this idea of providing knowledge to the LLM. So the research started way back in 2020, and that's what the first major paper was published. But you rightly said, see, I'm not the only one talking about RAG. Everybody understands RAG. It is also something that probably no modern LLM application exists without. So anywhere you go and you see some LLM being in production, most likely, about in 70% of the cases, it will have some form of RAG inbuilt in that system. But one important thing here was, I started doing this research myself in 2022, around April May timeframe, where we were trying to produce or generate content for brands that are aligned with their brand language, rooted in their data, being factually accurate about their services, their offerings, and what their value proposition was. But we realized that the LLM might not be able to do it right away. And that's where I got introduced to the concept of RAG. And I also realized, like you said, the term itself is quite intimidating, right? Like retrieval augmented generation seems like you have to do a lot of training, and you need to understand really complex techniques, and be aware of some really fundamental concepts in technology. But when I started delving deep into it, I realized it's not that difficult. And my whole purpose of authoring this book was, can we make it simple for somebody who wants to build apps with LLMs? And the way it started is, I started posting on LinkedIn, made some graphics, some graphical illustrations along with that, uh, created a short ebook of about 70 pages that I sort of published on social media. And then one of the editors at Manning, who goes by the name of Andy, he contacted me and said, "Hey, why don't you turn this into a full-fledged book that would really help people understand what the concept is in simple language? How do you build a simple RAG system? And then how do you go about really building on top of that, and introduce complexities into it, and also talk about how do you uh, deploy this RAG system into production?" So that's how I also sequenced this particular book. It starts at a very foundational level, where it talks about, okay, these are the challenges with LLMs, and this is how RAG addresses these challenges. And then taking a very simple example of a Wikipedia page, how do you build a simple RAG system? You have what kind of pipelines do you have to build, and then how do you evaluate these pipelines? So that's like the first two parts of the book talk about that. But you do realize that simplistic systems are not very useful in production. So to really deploy them in production, or make them highly accurate and useful for for your users, you have to do certain interventions. So from a really naive understanding of RAG, you build towards an advanced understanding, talk about modular architectures, talk about the whole operation stack, which enables the deployment of RAG into your systems. And then also the book finally concludes with some of the cutting edge concepts in RAG, like agentic RAG is almost a norm now, where you use LLMs as an agent while doing RAG, or graph RAG, where you incorporate knowledge graphs into your RAG systems, deal with multimodal data. And the last chapter in the book is sort of a revision of all these concepts, put into a framework that we call the RAG development framework, which is really helpful for developers to plan their project, plan their development, so that they can build a highly efficient RAG system, and make LLMs work for their use cases. So that's in brief, that's what the whole book is about. It is for people who want to get started with this concept of LLMs and building RAG systems, but also for people who are somewhat familiar with it, but want to get a double click and a second level understanding of what a RAG system is.
One of the questions I have about RAG systems is, how does the RAG system know what data you want? Because, I mean, if you say, one of the examples I was looking at today was talking about soccer stadiums, right?
Mhm.
In particular, he was asking about the Berlin Stadium. And so, is it the LLM that will take your sentence and then be able to figure out which things are more important than others in the sentence and know? Like, this is the question I have: is how do they work together, and what has what responsibilities between the two?
Oh, so that's a great question, because that is a great starting point for us to discuss about RAG. So one of the primary requirements of building a RAG system, or one of the first steps that you take, is to be able to create a knowledge base. This knowledge base is sort of the universe of facts and data that your system will work on. And this knowledge base can have a lot of things. It can have your personal information. It can have access to confidential information about your products, about your organization, something that is not in public domain. Plus, this knowledge base can also be connected to the internet to you know and do a search, like a Google search on the World Wide Web. So that is the first step of creating this knowledge base. And this knowledge base is where all the information for the LLM is fetched from. Now, how does this sort of this information uh, search and retrieval happen? Is that you have a component in this whole RAG ecosystem called the retriever. And whenever you are asking a question, for example, to this system, the first component that this question or this query or this prompt would interact with is the retriever. Retriever is really uh, an algorithm. You can think about it as a search algorithm uh, that will now go and search through this knowledge base that you have created, find the relevant documents or the relevant piece of information, like you said about a stadium, right, in Berlin. So when it the retriever gets this query that this question is about a stadium in Berlin, it goes and searches in the knowledge base. uh, that does the knowledge base have any documents that talk about a stadium in Berlin? It fetches those documents, passes those documents to the LLM saying, hey, there is this question about a stadium in Berlin, and these are the documents or the information that I have, where on which you should route your response. So so after this retrieval, after this fetching of documents, these documents along with the original question are passed on to the LLM, and now the LLM has all the information. So it has the question, it has the information where it should base it response on, and that's how this whole workflow uh, gets executed. Now there are further nuances into how what kind of retrieval algorithms you use, how you create your knowledge bases. But at a high level, this is how this whole idea of searching and the LLM knowing what information it needs to respond accurately, that's how this entire system works. I can also go deeper into how the knowledge base is created and what sort of techniques are used there.
Yeah, I mean, please. I'm really interested to know, how it all works because it sounds very, at a high level, makes sense. But then the details about how it all works it's eluding me.
Right. So, Alan, let's think about this. So, suppose there is a document that talks about a stadium in Berlin. How would you find that document? Like on our machines, on any system, you would do a control F and type stadium in Berlin and see, uh, you know, uh, and you would get highlighted those documents, or that piece of text would get highlighted, and you could easily say, oh, this is where it is. That's a very rudimentary approach to search, right? But when we are talking about practical uh, sort of in the practical world, uh, that won't give you a lot of meaningful information, because the question you're trying to ask the system may not directly have those terms that you would search on. So for example, I can say stadiums in Berlin, but all my documents, or let's think of it the other way. Let I can say, where can you play football in Berlin? And a response to that would be to find out about stadiums in Berlin or playgrounds in Berlin, right? But the question itself does not have anything, a search term like playground or stadium. But like, we human beings can intuitively understand that this is what is the meaning of the question. Now, how to make a system understand that? And that's where the concept of semantic similarity or semantic search comes in. And what does that mean? It means exactly how we human beings would interpret this question, saying, hey, this is a question. Where can I play football or soccer, for the sake of clarity? Where can I play soccer in Germany? This A response to this can have documents that involve the term stadium, or have a paragraph that talk about playgrounds and stadiums. Now I need to enable the system to be able to say that whatever is the meaning of this query and whatever is the meaning of the paragraph that has the answer are closely related. I'll introduce a concept called embeddings here. So, this particular idea of similarity is built into the system by this concept or data structure called the embeddings. What does embeddings really mean? Uh, so one thing, a starting point is like if we are working with unstructured data like text data, where we have documents and questions in English language that we need to find a similarity for. We know computers don't work with text; they only work with numbers. So now we need to convert the question into a numerical form, and these documents should also be present in a numerical form. And the numerical form that is very helpful in ascertaining similarity is a form called embeddings, and that's a popular data structure. So what embeddings do is that and it converts it into a vector form. This vector can be of any dimension. It can be like, just think of it as an array of say 1,000 numbers. Just let's build on this idea, right? And this and all the paragraphs that I have in my knowledge base are also vectors of 1,000 numbers, or arrays of 1,000 numbers. Now, when I plot these arrays in a multidimensional space, I these arrays will have a dimension and a magnitude. So my question will be an array in a multidimensional space, and all the documents will also be an array in this multidimensional space. Now, I calculate one of the ways of calculating similarity is the cosine of angle between two arrays. So, if two arrays are close to each other, the angle between them is zero, the cosine of that will be one, and we can say that this is highly similar. So, that's how semantic search happens uh, in the retrieval phase of RAG. You have your question converted into an n dimensional vector. You have all the documents in your knowledge base that have been converted into n dimensional vectors, and then the algorithm is trying to see in an n dimensional space which vectors are most closely aligned to the query vector, or the vector of the question that was asked to the system. And those are the documents that are fetched for the LLM to generate a response on. I went slightly technical, but I hope I was able to explain the concept.
Yeah, I'm starting to get it. It's something I really need to think about and kind of see it. What are some of the issues that come in with RAG though, right? Because for me, some of the issues that may come in is like if you, I remember I did see something about like kittens and cats, right? So if you ask a question about kittens, I mean, should I bring in the word cat and all the kind of resources around it because that could skew the results, right? So you could possibly have the wrong data being brought in.
Right, right. So when we are talking about like the issue, or the way we evaluate a RAG system, we should look at it in sort of in three dimensions. One of the node is the question that is being asked. The second node, we can say, is the data that is being fetched. And the third node is the answer that is being generated by the LLM. And in all three of these interactions between the question and the data and the LLM and the question, or the answer and the question, there can be problems in all of these three dimensions. So let's talk about them one by one. Let's talk about the interaction of the question with the data. So, what can happen? My retriever or the retrieval system can fetch some documents, but these documents are not really relevant to the question that is being asked. That would mean that my retriever is definitely not working correctly. So my this the precision and the recall of the retrieval system is really not good enough. So that can be one problem. So whatever data is being retrieved, that data is not really relevant to the question that was being asked. So that's sort of the first dimension. The second dimension can be between the data that was retrieved and the answer that was generated by the LLM. So, what can go wrong here is that even though the LLM is being provided with the data, it still does not adhere to, or is still not faithful to the data that is being provided, and still generating responses that are not correct. So that's a concept that is also called groundedness, like how grounded is the LLM to the data that is being provided to it. So that's the second sort of failure point in a RAG system, where you give it some data, but the LLM still does not take that data into consideration and generates its own answer that might not be correct. So that's the second aspect. And the third aspect really is between the question that is being asked and the response that is being generated. So what can happen is that you give the LLM the data very well is rooted in the question that was being asked, but the LLM does not pick the portions of that data that are relevant to the question being asked, and it gives a correct answer, an accurate answer, but that accurate answer is not really relevant to the question being asked. So the answer relevancy is not that high. So these are the three dimensions in which RAG systems can go wrong. And and that is also the main evaluation that happens when you are developing RAG systems, and there are certain interventions to address these failure points and increase the overall accuracy of the system.
Well, now that you've mentioned these failure points, right? Um, is there ways that we can safeguard or even protect against not having these issues? Is it just constantly like testing and making sure that we can handle different kinds of problems and the LLM can try to correct these kind of things? Or what do you kind of recommend? Because the problem that I have these days is like I was talking to somebody yesterday, and you know, they made a claim and they just typed into Google, and Google now has that AI, you know, summary. And I remember
Yeah.
a long time ago, maybe it's probably better now, but a long time ago, the AI summary from Google was telling you all kinds of crazy stuff. And I think it would even list some sources and stuff too. And even
Yes.
with sources, you know, like Reddit, right? They'll tell you whatever to see if you believe it. So I guess my question is that, you know, how can we help to safeguard so that we're actually getting accurate, real generative answers from LLMs using RAG?
Yeah, and that's the $1 million question, right? How do you make your system more accurate? And there is no straightforward answer to that. And the reason is that these algorithms, the LLM itself, the retriever, they're all probabilistic, right? So there is, no matter how efficient a system you build, you can never claim that it will always be 100% accurate, because they are probabilistic in nature, unlike some deterministic algorithms or expert systems that you may have. These are all probabilistic algorithms. So all you can do is test while developing and do continuous monitoring to really preempt the quality of the system degrading. So the first step is, like, during your development phase itself, you have certain data that you will be benchmarking against and evaluate your system, on these three dimensions that we talked about precision of retrieval, about the groundedness or faithfulness of the LLM, and the relevance of the response or relevance of the answer to the question. So these three dimensions, you evaluate your system based on certain test data or ground truth data that you already have. So evaluation is one, but suppose your evaluation tells you that, hey, the numbers are not very high. So what do you do then? Now, in these simple uh, things that we have mentioned, like there is a question, there is a retrieval component, there is the LLM that generates answers. In this workflow, there are certain interventions that can be made. The first intervention is in the knowledge base that you're creating itself. Now, knowledge base can have a lot of different data structures or databases in the knowledge base, right? There can be something called vector databases that are very efficient in searching for embeddings. There can be knowledge graphs there. There can be your traditional SQL databases, NoSQL databases there. So the first sort of advanced intervention that you can make is to optimize the indexing of your knowledge base, and this can happen through various techniques that are there. So one thing you can do is really think carefully about how you are structuring information in your knowledge base so that it leads to efficient retrieval. You can also sort of control the quality of the data that is there in your knowledge base at the time of creation. So you can add a lot of metadata information so that retrieval becomes more efficient. You can check for facts in the knowledge base. You can remove PII or confidential information. If there is conflicting information in your data, you can resolve it at the time of creating your knowledge base itself. So the first intervention comes at the creation of this knowledge base. Now, once the knowledge base has been optimized, uh, we can sort of and there are other more specific techniques, like there is a concept called chunking in RAG. So how do you create efficient chunks? All that can be used to optimize your knowledge base. Now, once your knowledge base has been optimized, you can be fairly confident that if I am searching in this knowledge base, whatever inaccuracies in the retrieval will not come because of information not being stored correctly in the knowledge base. There can be other reasons why this may happen. Now let's come to once we have the knowledge base, now let's come to this flow of somebody inputting the query or entering the query, the retriever searching and retrieving the information, and the LLM generating the response. The first intervention, let's say when we're talking about the first point of failure, it can be because the question is very ambiguous, or the question that the user has asked is you there is very little to understand from that. So what can you do in those cases is that you can optimize the query itself, and query optimization can happen in a lot of ways. You can ask the user to sort of maybe shed more light or elaborate the query. You can have modules that rewrite the query, transform the query, or expand the query uh, into multiple subqueries, and all these subqueries can be used to retrieve more information. So what that does is that you don't miss out on a lot of data, and because you are sort of transforming the query, you can also transform it in a manner that makes your search result be better. So that's On the query optimization, you can optimize the user's query using certain interventions. Then let's come to the retriever part. The retriever itself, one thing like we talked about, can be very simple: control F, search for the term, and you get it. And there has been a whole evolution in how retriever algorithms have evolved. And I'll talk about the uh, most recent and the most popular way now in doing retrieval is by doing repeated retrievals. And there can be very many ways in which you sort of the retriever goes and searches for the documents once, analyzes whether these documents are really relevant, picks those relevant documents, discards the irrelevant documents, further analyzes these documents to say, can there be more information that can be fetched, and creates more queries, searches for more uh, documents in the knowledge base, and comes up with a collection of documents that are highly relevant, and also quite comprehensive, that can be used in answering the user's question. Now, that's on the retrieval stage. The retrieval algorithms can be made better. Now, once you have your retrieved documents, there is another intervention that you can make to really pass only relevant information to the LLM. And there comes the concept of re-rankers. Now, re-rankers have also become big in the concept in this whole paradigm of RAG, where you take all the documents that have been retrieved by the retriever, and there is a re-ranking algorithm that establishes the priority or re-establishes the priority of these documents. And then you can say, hey, I will only pass the top 3 to the LLM, for example. So now LLM has the most relevant information that can be fetched from the knowledge base, uh, uh, which is relevant to the user's query. And now, because LLM has this very relevant information, the idea or the belief can be that now LLM will produce better results. But you can even do interventions after the LLM has generated the response, uh, by introducing this idea of reflection, where the another LLM or a different system analyzes the quality of the response. And if the quality of the response is not deemed to be very high, then you can go back to the flow and do more retrieval, do a better generation, and really improve the outputs of this whole RAG system. So there are various interventions that can be done. uh, Depends on use case, but these are iterative in nature. So you do your evaluation, you find out which failure point is impacting the overall quality of the system the highest, uh, do these interventions in those stages, uh, evaluate again, see if things have improved. If they have, then good, otherwise do more intervention. So there's this whole iterative angle to the development of a RAG system. And then when you are fairly confident, release it into production. And even in production, continue monitoring, is any aspect or is any failure point getting triggered, so that you can do an early intervention in improving that part of your RAG system. I mean, a lot of sort of uncertainty there, or a lot of continuous monitoring involved, but that's how all probabilistic systems are built these days.
Kind of glancing over your book, you talk about something called rag ops. Do you mind to discuss? I guess this is a term you made up yourself, or is this actually a term in the industry people know about? Because it's the first time I've ever heard of it.
Yeah, I made it up myself. It's like you have LLM ops, AI ops. Right now, I came up with this term of RAG ops, and I see now it is being used in a lot of places. But this is really an extension of LLM ops, or you can also call it a sub component of generative AI ops in general. So if you're building AI systems, then you would need these different components, right? That enable you to develop, deploy, monitor uh, uh, these systems. So, like I was saying, right, there are different layers when you are creating a rack system, and there are some fundamental components of the rack system. And the first sort of the foundational layer there would be of this knowledge base or data, right? Like, what data do you want the system to generate responses on? I was talking about knowledge base optimization. So, how do you store that data? How do you clean up that information so that it is ready for retrieval by the rack system? So, that's sort of the first layer in your operations stack. The second layer would be the models themselves. Now, models can also be of different kinds. You can have LLMs that have been developed by proprietary providers like Anthropic or OpenAI, uh, or you can have open source models that you're either using provided by a managed solution provider, or you are deploying them in your own infrastructure and have your own models there. So the model layer becomes uh, the next layer, and within the model layer you can also store your retrieval algorithms, right? Like the algorithms that would uh, do your retrieval. And then there is this whole orchestration layer, or the orchestrator in the middle, that is interacting with the application, the input and output component of the system, and managing, when to fetch data, when to call the retriever, when to pass into information to the LLM, what to respond to the user. So the orchestration layer then interacts between the model layer, the data layer, and the input and output application layer. And these form really the critical components of your stack. And then you add evaluation and monitoring to it. Prompts are how LLMs are used, and very important to understand prompts and manage prompts. So prompt layer is another layer that you can have in the middle. With LLMs, there are new threats and new security and privacy vulnerabilities uh, that have uh, that have come into the picture. So the whole privacy and security layer is another essential layer uh, in your stack. uh, and then, of course, depending on the use case, you can have different layers. You can have a human in the loop layer. How do you manage the approvals and interactions with a human being? uh, uh, and sometimes you might need to develop your own models for some intervention. So that experimentation layer is another sort of layer that you can have in your stack. And the way I look at it is that there are three levels of components. There are the critical layers, the first four layers that I talked about, that are very important in developing a foundational system. And then there are essential layers like prompt management, like evaluation, security, monitoring, that are really essential when you're building something for production. And then you have these enhancement layers like human in the loop, like experimentation, modeling, that are use case dependent, but elevate or focus your rack system towards the use case you're trying to solve.
Okay. There's definitely a lot of layers involved. Well, I'm happy to hear that your book is definitely called A Simple Guide. I mean, you covered a lot of topics. I think it's not a very big book, right? I mean, it is called Simple Guide, but I think, obviously, like I said, I don't have the. Okay, so it's 256 pages. The core of the book, is it really easy to understand? Do you take everybody through a nice pace, because
Yeah.
it's quite complicated topic, even though it's simple at a high level.
Yeah, the real challenge with RAG is that it is very simple to understand as a concept, but there are a lot of nuances when you are trying to uh, build a RAG system. So in the book, we go through that journey. There are about 220 to 230 pages of actual text in the book, if you remove the cover pages and indices and all of those. Uh, so what we also do is, in the book there is also accompanying code. So while the first two chapters deal with foundational knowledge, chapter 3, 4, and 5 help you understand the creation of the knowledge base using an indexing pipeline, very at a very fundamental level. And there is also accompanying code in which you can try hands on, which is not very deep or complex code. You can try hands on and build a knowledge base, an example or illustrative knowledge base for yourself. Then in chapter 4, we interact with this knowledge base and ask questions, and through this generation pipeline get responses, and that is also accompanied with code, and you can try it out on the knowledge base that you have built. And then in chapter 5, we talk about evaluations and these failure points and how you can evaluate your rack systems. And that is sort of the core of the technical understanding of how rack system works. So that is covered in the second part. And it's in a very simple language with illustrations, so that it's easy for somebody who's not familiar with the technology to understand. Now, chapter 6 and 7 is where we go a little advanced, because, as I said, your uh, fundamental, or your basic foundational rack system will be plagued with these failure points. So, in chapter 6, we talk about these advanced techniques at a very conceptual level. Like I said, optimizing your knowledge base, optimizing the query, the retrieval, the re ranking, the generation. So we talk about them at a conceptual level, and there are also examples or snippets of code that you can try hands on to see how it improves the accuracy of the system, or the efficiency of the system. And then in chapter 7, we talk about this whole rag ops. So when you're thinking about building these systems, we talk about these layers that I uh, just told you about. uh, Chapter 8 sort of talks about what readers can do or find out further about, like multimodal rag, like graph rag, like advanced rag techniques like agentic rag. So we just give a brief introduction of these concepts, and then there is also accompanying code, but really it encourages readers to then go in these directions of their choosing. And if you look at the last chapter, which is chapter 9, all that we talk about in the book is sort of summarized in this chapter, but it is summarized in a way that you can plan your development project, rag development project, using that. So we introduced something called rag development framework, which has sort of 6 different dimensions that you can go through while you are creating a, or you are embarking upon a rag project. So all of this is very simplistic. Of course, when you're trying to build it, there will be certain technicalities that you will encounter, and the book does not talk about those deep technicalities. That is left for the user or the reader to then explore further. But this is sort of a holistic idea of what rag is, and what do you need to look further for when you're building your own rack system. So the idea is to provide a very gentle introduction to this technology, to the concept, but also at a very high level be comprehensive in talking about, okay, what all would you need to build a rag system.
Okay, that's a pretty comprehensive, simple guide. Uh, but I'm guessing since it went through all the process, it must be in a way that should be easy enough to understand. Yeah, I mean, I think we're starting to approach the time. You're definitely given a lot of information. I do have to say that we should have a discount code for people who are interested to buy the book, but definitely get it directly from Manning because you're going to get a better deal. And yeah, like I said, and also more money goes straight to the author, which is most important. Do you have anything that you wanted to leave off before we sign off?
This is my first book. Even though I've been sharing a lot of knowledge on social media, I never sort of formalized that into a book. So it was a very exciting process for me, and that is my takeaway from this. I would want to write many more books going forward. And the idea that I wanted to leave with the listeners of this podcast, and also the readers of my book, or anybody who's interested in this technology, uh, this is a very transformative technology. LLMs, generative AI in general. We are seeing application of this technology in industry. I work with a lot of clients who are using LLMs and other generative models to get efficiency in their business processes, to derive more value out of their data and really enhance customer experience. So this technology is a transformative one. There's no doubt about that. Even though there will be periods of disillusionment, but the trajectory will always be upwards. That being said, it is also an evolving technology. You hear about new research, new models, new papers coming out every second day. So it's very important for you to, if you're interested in this technology, to get a solid grasp of the foundations of the technology, which about RAG you can get from this book, but there are other books also about LLMs, other models at a very foundational level. So that is very important. And then you keep abreast with news and technology advancements, because they're happening at a very rapid pace. So I would suggest build a foundational strength in understanding of the technology, and then there is a lot of information out there that you need to continuously be aware of, try out, and see what works for you. That is what I would want to leave the listeners with.
Okay, great. And with that, again, thanks you for coming on. Well, I hope that what I always usually hear from authors is that it's like, once you finish, when you're at the end of finishing the book, you're like, oh, this is terrible. I don't want to do this ever again. You finish it, you're like, maybe I will. Let's see. You have this product, this output, right, from something from it, as opposed to when you're working on it, it's a lot of effort and you have no tangible like benefit until it finally comes out in people's hands, right?
Yeah,
So
yeah, yeah. You're right. You're right. But it's exactly the same for me. I was tortured during the process, but with the final result, I was so satisfied that I would want to go through it again. But thank you so much, Alan, for having me. As I said, it's a privilege talking to you, to your audience. I would love to talk to you more about technology and things in general. It was a wonderful experience for me. And
it's
I
also
hope
great to have you on. Yeah, well, hopefully we'll have you on again. I'd love to see what your next book is about. So maybe it's about a new augmented, way to interact with LMs. Who knows what's going to happen in the future?
no, you don't know. Nobody knows.